Okay, so really I'm hoping you haven't had to watch this video, that you were able to solve the first part of your investigation pretty much by yourself, just from the hints we gave before. But this is a similar one. We'll work you through in case you got stuck, and hopefully you can compare the pair. Pretty similar. We've got a quadratic function here, the black line. We've got a linear and a linear. We know that at x equals 0, so when x is 0, the slope is minus a half, and when x equals 10, the slope is 6/5. Okay, let's just put that there. Put all your information, always do that. So what information can we gather so far? Well, if we go back to f of x, if we look at that, we now know that because it's going through the origin here at 0, 0, we know that the y-intercept is also 0. We know that because the slope is minus a half, because that's the tangent at that point, this means we've just got minus a half x. So f of x is pretty much done and dusted. To get our quadratic, let's have a look at what information we have. We've got that g of x, any quadratic, is of the form ax squared plus bx. I'm not going to write the c because, again, we know that our c, it's our y-intercept there, and it's 0. So we've got that. We also know that it too, 0, 0, also passes through or is on the quadratic, but if I substitute 0, 0 into here, it's not going to get me anything. Everything will cancel out. So now we're going to go to, we haven't used calculus. What can calculus get us? Well, we know that g dashed of x equals 2ax plus b, and because we said that this blue line is indeed the tangent when x is 0, we know that g dashed of 0 must equal the slope of the tangent, which we already know is a half. So we've got that is a half. Now if I substitute in, we've got a half. When x is 0, 0 times 2a is 0, so I'm left with b. We've now got g of x equals ax squared minus a half x. It'd be really handy if we could find a. So now we're going to turn our attention to our red linear function. And what do we know from that? We know a couple of things. We know that, just do my working over here now, we know that if we call this h of x, we know that h of x will so far be 6/5 x plus c. And therefore, again, this is another tangent of the quadratic. And so therefore, going back to our g function, we know that g dashed of 10 must equal 6/5. Hope you agree with that. So back up here is our g dashed function, so we can now say that 6/5 equals 2 times a times 10, so that's going to equal 20a plus b, but remember we know that b is minus a half. That allows us now to find a, so that's going to be 6/5 plus a half equals 20a. So just get our trusty calculator out and work out 6/5 plus a half, and we want to divide that by 20, so we end up with a equaling, sorry about that, so a equals 17 over 200. And now we've got our g of x function. So g of x is 17 over 200 x squared minus a half x. All that's left for us to do now is work out our c. Now remember, this coordinate on our graph here, it's on the quadratic and it's on the straight line. So 10, how am I going to get the y value? Or I could pop it in here, but that's not going to be very helpful because I don't know c. Whereas if I popped it into the g of 1, so if I find g of 10, wherever x is here, I replace it with 10, because we know that g of 10 is going to equal h of 10. So that equals, pop that in, so that equals 7 over 2. Or you could have just substituted in your h of 10 there over here. So what we're saying now is h of 10 must equal 7 over 2. We're saying that's the point there. So we've got 7 over 2 equals 6/5 times 10 plus c. So c will equal 7 over 2 minus 6/5 times 10, which gives us minus 8.5. Therefore, h of x equals 6/5 x minus 8.5. What you want to do now is graph these over the domains that we have. So for h, I guess that's between 10 less than or equal to, x is greater than or equal to 10, and maybe put that up to however far you want to go. It's your choice as to when you want the next function to start. If we just say 20, and the domain for f of x, that's going to be anywhere from minus, so whatever you want, minus x, but it's got to be less than or equal to 0. And the domain for your g of x function, which is this one here, that's going to be between 0 and 10. So looking at the video where we showed you how to use your technology, either using FXdraw, Geometer Sketchpad, GeoGebra, or Desmos, or any other package that you might have come up with, make sure that you can graph these and see that they do in fact form a nice smooth curve. If they don't, well, go back and find an error somewhere. So for those of you using FXdraw, I've just popped these equations in. 3 that we had here, I went from -4 to 0, 0 to 10, and I went from 10 to 15. So when we press OK, the proof will be in the pudding as to whether they look like they are flowing, and that looks pretty good. So it looks like it's a nice flow, and you could back that up with maybe looking at second derivative to show that it's smooth, or maximum points and all that sort of stuff. All right, so that works. Good luck. Hopefully that helps you with your investigation.